Welcome to episode 71 of Talking Dairy. On today's podcast, we will be focusing on DairyNZ's key research initiatives, providing farmers with solutions to help improve water quality and meet changing regional regulations. We'll be talking with DairyNZ Senior Water Quality Scientist Dr. Katrina Macintosh and AgResearch Senior Scientist Dr. Richard Muirhead. They'll be talking about key initiatives which are making a difference to water quality across the country. Firstly, we'll be discussing how adopting good farming practices in 5 dairy catchments has led to improved water quality over a 20-year period. We'll also be highlighting how a new research initiative aims to better understand how to reduce E. coli loss into waterways in farms across Manawatu.
Kia ora, Katrina and Richard. Welcome to the podcast. Richard, before we get into it, I would love to hear where you hail from and how did you come to be researching water quality?
Yeah, I live nowadays down in Dunedin and work out of the MMA campus at AgResearch. I've always been interested in water quality. I grew up on a farm and always, as a kid, always playing around in the Ashburton River, Hakateri River, and the streams on the farm. And then as I grew up, went to university and started studying microbes and water quality and just transitioned into that space. Always find it interesting.
Brilliant. And how about you, Katrina?
Yes, somewhat similar. I grew up in rural Northern Ireland. My uncle and my grandfather were dairy farmers. My father was keenly into the environment. So as children, we were always taking us walks and, enjoyed some of the rivers that were local to us. And from there, got interested in water quality and sort of catchment science and did a degree in environmental sciences and then went on to do research work there back in Northern Ireland and then moved to New Zealand to take up a job with DairyNZ as a water quality scientist 4 years ago.
Both hailing from farming backgrounds. That's awesome. I'm going to start with a silly question, Richard, because I listened to a talk that you did at a Beef and Lamb conference in 2017 and I learned some things I'd never heard about before. So silly question, but what is the problem with cowpats getting in the waterways?
Yeah, so we use E. coli as an indicator of water quality within the water systems, and that's because E. coli is found in the feces of warm-blooded animals and of humans as well. And so we suffer from a whole lot of diseases, which is spread by the fecal oral cycle. So this is a nice bit of stuff to think about, but when someone gets sick and you have diarrhea and you run to the toilet, we're spreading those diseases in large numbers out in our feces, and they get spread out into the environment, and we can ingest them again either through food or through water or drinking. And within the bunch of diseases that we can get spread by these fecal oral cycles, there are a whole lot of diseases we call zoonoses. And these are diseases we share between humans and animals. And so some of the really common ones that you'll be aware of is Salmonella, Cryptosporidium, Giardia, and Campylobacter. And so animals have the same diseases that we do, and so therefore animal feces contain a risk to human health if those feces are deposited in the environment. And it's really important to remember that for all of our cities and our houses, we have septic tanks or sewage treatment plants that we use to separate the fecal material from humans and try and keep it away from waters until the risk is reduced. But for a lot of our farming landscapes, we have animals depositing feces all over the environment when it gets into water.
Obviously, the zoonoses aren't the whole picture. What else do we need to think about or are we looking at with water quality, Katrina?
Sure. Once also then considering things like nutrients like phosphorus and nitrogen and the impacts those have on our waterways when we get increased concentrations of those, which has knock-on effects for ecological function. And also consider things like suspended sediments, again, sort of increasing their turbidity within the stream or river water column. And also that can have, as that material deposits out of the water column and onto the stream bed, can have impacts for clogging up, spawning beds for fish and the impacts on macroinvertebrates in terms of breathing and gill function with fine sediments.
So it's really complex. So Katrina, tell us about the research into improving water quality in dairy catchments and why this is a vital piece of work for farmers.
This has been quite a long-running research project, which has been supported by DairyNZ. My co-authors on it are Professor Rich McDowell at AgResearch and Craig Dupree, who also works at DairyNZ. And what the study has shown is that the adoption of good farming practices on dairy farms has helped to reduce contaminant losses into waterways and improve water quality. The initial project was around, or called the Best Practice Dairy Catchments Project, and it ran from 2001 to 2010 in 5 dairy-dominated catchments. 3 are located in the South Island, in Waikiki in Canterbury, Inchbonny over in the West Coast, Bogburn and Southland, and then 2 in the North Island, Tuanipi in the Waikato and Waiakura in South Taranaki. And basically what happened was, the science provided farmers advice and helped them to develop up farm plans with mitigation strategies to reduce contaminant loss. The project then continued to monitor water quality and carry out the farmer practice surveys from 2011 then to 2021, which allowed us then to amass a long-term data set. And this has allowed us then to assess and look at water quality trends and metrics over the 20-year period to see how the implementation of those good farming practices had affected water quality. A variety of mitigation options were adopted, for example, improving effluent management on farm and phosphorus fertiliser use, and then also stock exclusion from waterways as part of the Dairy Clean Streams Accord. And the results from that study were published in the Journal of Science of the Total Environment in October 2023. And you also can find more information about it in the October-November edition of Inside Dairy. And there's a link to the paper there as well.
So what kind of farmers get involved in research like this, and what motivated them to be involved in this research?
Given that it's been a long-running project, it's been going for 20 years, the initial setup predated me and, living and working in New Zealand. But at that stage, and looking back, it's around those small dairy-dominated catchments and, that interest and the desire to improve water quality and see which actions work. And that was particularly, even with the most recent practice change survey that we did, through DairyNZ and the baseline dairy-based team, that interest in participating to provide the evidence base for improved practices and, are they working? And then basically gathering that data set to, support that.
So how did the changes farmers made affect water quality, and what improvements has this led to?
What we found was that over the 20-year period, 2/3 of the in-stream water quality trends were showing improvement, and that the adoption of those good farming practices helped to decrease ammonia concentrations, phosphorus, suspended sediment concentrations as well, across the 5 study catchments. And the water quality improvements, then we were able to attribute those back to farmers adopting those good management practices around, for example, effluent management and phosphate fertiliser use, and also then the exclusion of stock from streams and waterways through the Dairy Accord as well, that ability to prevent stream bank erosion and increase sediment release. However, we did find that several water quality trends were also degrading, especially nitrate, nitrogen and E. coli. And Richard and I are now working on a new research initiative around E. coli and cover aspects of that then in this podcast.
So yes, as Katrina mentioned, Richard, you've got a new research program underway in the Manawatu focused on E. coli. Tell us about what that aims to do.
Perhaps a little bit of background first, because E. coli is probably one of the least understood of the 4 freshwater contaminants. So our Land and Water did a study recently where they looked at nitrogen, phosphorus, sediment and E. coli levels right across New Zealand, and in terms of how they met with the desired standards we have for water quality in New Zealand. And E. coli come out the worst of all of those. So E. coli levels are probably too high in about 75% of our areas in New Zealand. So it's really good that we've got this project underway, starting to fill the knowledge gaps that we have in here. One of the reasons we're working in the Nutaroa catchment and the Manawatu is because there was a local group of farmers who got together themselves and set up their own research monitoring a number of years ago. And they've got to the point through their own monitoring where they've discovered that E. coli is the biggest issue that they have in their catchment. And so they're a really good group of motivated people that we can get in and work with. One of the other challenges you have with E. coli is that it's a little bit different to other contaminants in terms of timing effects. So one of the water quality issues you can have with nitrogen and phosphorus is the growth of periphyton in water, which smothers the surface of rocks and things and grows. So you need a reasonably high level of nitrogen and phosphorus in the water for a reasonably long period of time and some warmth and sunlight for that periphyton to grow. So you kind of need an averages there. So you could get a huge spike of nitrogen that would flow quickly through a stream and wouldn't have any long-term effect. But because E. coli is related to disease organisms that cause illness in humans, all you need is a single spike of contamination occurring at a time when a person happens to be recreating in the water, either grabbing mahinga kai or having a swim, that can cause those issues. So in some ways, in E. coli work, the risks are driven by what people would call a statistical outlier. And they're the key things that drive those risks, and that makes it quite difficult to understand. Also, E. coli is stored within the catchments and within the soils. The main source of it comes from the feces of animals, but we know that from multiple rainfall events, some of that E. coli gets stored in the soils for a time period and then moves on to the stream, and then it can be stored in the sediments in the bottom. And we don't really have a good understanding of how all these transfers are occurring within a catchment and how that leads to the E. coli levels that we're seeing in the water. So this project has a really large focus on developing catchment scale models so we can link what's happening on farm and when the E. coli sources might be leaving from the farm with those water quality standards that we're looking for that protect human health. And so the catchment project has a lot of focus on catchment models so we can extrapolate what we learn in the Nuturoa to other parts of New Zealand, but very much using the Nuturoa to ground truth our understanding and being able to go back and test things that we learn from the modelling work we develop.
Katrina, why is this a key work stream for DairyNZ, this new E. coli research?
Sure. I mean, the value of, this collaborative project between the two organisations and the fact that, it's a multi-year funded programme is great. It gives that expertise and time to unravel some of the complexities that Richard has been chatting about. And, the value to DairyNZ as well, around co-developing the research with AgResearch and also with the catchment group, and doing that through collaborative meetings and also boots on the ground regularly to get a bit of a feel for the catchment. And it's also been really good to work with the catchment group, Christine Finnegan, Rob and Xandra Thompson, as well as others in the catchment group to really get an understanding of the issues and the pressures that we're trying to address. And the ability to do that with AgResearch and the expertise that are there, through DairyNZ, collaborating there and then extending out to the catchment group.
Coming back to you, Richard, how do you actually measure E. coli in the water?
Well, the traditional way that you would measure microbes in water is that you would take a sample from the water and you would assume that the bacteria you're looking for is in there. Then you'll put them on different growth media in the laboratory and you'll put them at the right temperature and grow them generally overnight. And so if they are there, then they will grow and you'll be able to see them either on a plate or see them in a liquid medium by using fluorescence materials. And then from there, you can back calculate how many bacterial cells there were in the original sample when you took the water sample.
Have you discovered anything interesting so far in this research?
Yeah, we have found some good challenging work for us. The original sampling work that the farmers had done in the Nuturoa catchment had taken samples from... So we need to think of the Nuturoa catchment as sort of starting up in the hills with perennial streams that start flowing off the hills. It goes down through a series of farms and into the flats on the bottom. As it does that, it transitions from an area at the top that's actually been converted to pine forests and had animals removed from that, down through a series of dry stock farms and into dairy farms at the bottom. The Nuturoa catchment group themselves had sampled right up at the hills where the water was really low, so the average E. coli concentrations was less than 10. They sampled a site at the flats where it crosses the state highway there, and the average concentration is 1,000 E. coli per 100 mil in the water there. And given the median required for good swimming water quality in New Zealand is 130, that number is really high. And that's only over a distance of maybe 5 kilometres. And so that's a very rapid increase in E. coli concentrations. And what we've done in the start of this project is, in between those two sites that the farmers themselves were measuring, we've gone and set up another 15 different sites. We're getting water samples from a whole range of areas, and we're starting to see that pattern in multiple streams across the catchment, but also we're seeing a steady increase as the water flows down the hills. So we're getting the same numbers they were, which is not surprising, but we're getting to see the concentrations increase as the water flows down. So that's good. That's what we expected to see, but it's definitely going to be a really big challenge to test our understanding and build models that explain those numbers in a way that we can then link it back to what's happening on the land.
Okay, so how will this research help farmers in other regions if they decide that they want to reduce E. coli in the future?
Yeah, I mean, a lot of the basic things that happened on farms with animals grazing in paddocks and runoff from rainfall events and different management systems are very similar all around the country. So the findings we get from here will be translatable to other areas. But also that's one of the main reasons we have a large focus on the modelling work, because then that enables us to extrapolate things to different parts of the country.
I just want to come back to you, Katrina. You talked about how a lot of the water quality measures have improved over the last 20 years because of the changes farmers are making, but nitrate and nitrogen and E. coli were still degrading despite farmers' efforts. Can you explain that to us a little bit?
Sure. Around, particularly the nitrate and nitrogen, it's a product of increased intensification of the sector. And, with that, more land production being brought into dairy, increased nitrogen fertiliser use, increased use of imported feeds and things like that there. So you're just sort of creating more nitrogen within the system. That said, DairyNZ is currently researching a lot within the nitrogen mitigation space to how to help reduce that, and then also limits around synthetic fertiliser use, as well as coming in has come in to sort of help try and redress judicious fertiliser use. So all those are basically helping to contribute to, the next stage of addressing some of the nitrate work. Because as we could see, a lot of the mitigations, particularly around phosphorus and sediment, have been implemented, things like stock exclusion, effluent management, soil testing on farm. And that was something that came through quite clearly with the revisit or the last farmer survey through the best practice dairy catchment. There's the number of farmers that are regularly soil testing and how that feeds into their nutrient management plans. So those actions we're able to see now in that 20-year water quality data set and trends that, those actions are having an effect. So we've got, the work on now in terms of nitrate and, the things like plantain, some of the stacked N mitigation work, for example. We're researching in that area to give the sort of solutions and tools to address that. And then with this project with Richard and AgResearch, we can then further delve into how to best manage E. coli.
Outside of the catchments that you were working with, how widespread are the farming practices that were adopted in that research?
Yeah, I mean, farmers really have undertaken a lot of work over the last 20 years to improve water quality. And, the work from the best practice dairy catchment revisit has certainly demonstrated the positive outcomes of those efforts, as well through the Sustainable Dairy Water Accord, the sort of exclusion and installation of bridges and culverts and stocking points. So keeping cows out of waterways is important. And then also farmers are also starting to undertake riparian planting alongside the stock exclusion, and also sort of restoring and constructing wetlands, also to help with, contaminant remediation in terms of nutrients and sediments, and also more efficient fertiliser use. So that was coming through with the farm practice surveys over time in that project. And also in another project that I'm currently working on is looking at analysing the state and trend of good farming practices on dairy farms, but using DairyNZ's baseline project database. That's a national data set, and it runs over a 10-year period. But the work is investigating what good farming practices those dairy farmers have been implementing, and basically highlighting areas for improvement, but doing that in a larger data set as we would get with baseline.
I'm interested in hearing from both of you what the benefits are of having a number of research partners participate in projects, and also why having farmers involved is important.
So yeah, it's always good to have farmers involved directly in your project because they keep you grounded. They're always practical, forward-looking people, and they're asking, like, what is it I need to do? Which can be a challenge in science because science is always a slower process about building up data and knowledge. But they're always asking you about what they need to do and how it will fit in with the system. So if you work with the farmers from the beginning, you're going to end up in a place that's much more practical. So while I'm looking at a project and thinking about E. coli, the farmers are then thinking about, well, what about animal welfare on my farms? What about the economics? Will this change my labour needs on the farm? What else will do? So if the farmers are there from the beginning, they help you get to a more practical and more useful place at the end. And then working alongside DairyNZ as well, they have a huge extension arm of rolling out and encouraging good practice across New Zealand. And having them as part of that project means the science is going to be taken up and used a lot quicker than it would be if we'd just worked on our own.
Did you want to add anything to that, Katrina?
Yeah, just to reiterate what Richard has already said, that partnering and collaborating is key, to delivering that high quality research and achieving those best outcomes, and through those collaborations with AgResearch and, with the community group and things like that there, we all bring quite unique and complementary skill sets and viewpoints. And it's leveraging that to basically try and address the water quality challenges that we face. And as such, we value that strong relationship with AgResearch, working on this project and on other ones. And, as Richard was also saying, that ability to tackle problems together often makes things more manageable, and particularly with the farmers, and the catchment groups as well. It gives you that sort of valuable local insights at the farm scale and at the catchment scale. And that helps us to better understand, well, what is practical on farm, and you get that information through the farmers, And also that community support and buy-in, is really key for developing trust and relationships. And, and that's great. That enduring relationship's really good for continued adoption of good farming practices on farm and through catchment groups.
Well, thank you both so much for taking the time to talk to us today about water quality and how much farmers have done in that space and the benefits we've seen in water quality as a result over the last 20 years. And also, Richard, the research that's now underway in relation to E. coli, which remains a bit of a challenge for us. Mā te wā, noho aro mai.
Thanks for tuning in to this episode of Talking Dairy. Check the show notes on where to go for more information on this topic. And if you have any ideas on future episodes, please send an email to talkingdairy@dairynz.co.nz.